Now, a particularly interesting problem that usually pops up when you're studying mass spectroscopy is the mass spectrum of chlorine. Now, this video is intended for people who have gone over these four things that are written here. Mass spectroscopy, isotopes, relative abundance, as well as diatomic molecules. So when we look at the mass spectrum of chlorine, we see that first of all, we have the two expected peaks at the 35 isotope and the 37 isotope right here. So those are expected. But then we have three other peaks right here, the one at 70, one at 72, and one at 75. And what I often see is a question asking, well, what are these three? What are these three brackets over here, or rather, what are these three lines here representing? And in order to explain this, we have to first kind of explain what the mass spectrum is really analyzing. So when you have a mass spectrometer, what it's actually measuring really is the relative density of a stream of chlorine atoms. So for example, if we have our mass spectrometer here, it's probably a better image. It's like a tube almost, with this curving in and this curving in. And then there's a magnet right here. There's a magnetic field that transfers through this area right here in this loop. And so what ends up happening is that you have a bunch of Cl2 that goes through here. And then some of the bigger atoms, since they're not as affected by the field, they continue on going forward. And those get picked up along here. But some of the other atoms that are lighter, they get affected by the charged field more, and so they curve more. And then so they end up here, and that's how you end up with this abundance. Now, the important fact here is that it's a stream of all Cl2 atoms, which means that in finding the stream, a lot of naturally occurring ions can form. So what that means is that not only are there Cl35 and Cl37 ions, there are also combinations of both. So what that possibly means is that there are also Cl70 and Cl72 and Cl74 ions. And this represents a diatomic combination of Cl35 and Cl35. 72 represents a diatomic combination of Cl35 and Cl37. And Cl34 represents a diatomic combination of Cl37 and Cl37. So already you can start to see why we have these three extra peaks forming over here. This one at the 70 mark is the isotopes of the two Cl35 atoms. This right here at 72 is the combination of 35 and 37 atoms, or 37 and 35, vice versa. They give you the same mass. And this third peak right here is a combination of the Cl37 and other Cl37 atoms.